given that analog multiplier to multiply two sinusoidal circuits. Right. First, the power supply is connected here, as you can see, for the minus 10 volt, plus 10 volt, and then we connected the inputs. The first input is connected to X1 here, and the second input is given to Y1. And then X2, Y2, and Z2 are taken to ground, connected to ground, and then this output wire is connected here, and then we connected the 1 by SF to minus 10 volt.
Okay, so we have now performed a multiplier circuit in which we have given the first input as 1 kHz with 1 VPP and second input as 10 kHz with 2 VPP. So here we can see that the output, after we use the multiplication circuit, we get that our output has several frequencies, and we can average out using the average function which is given in the acquire. So we will check with the FFT, and in the FFT we can see firstly we need to reduce the scale. So as per the theory, we will get F1 minus F2 and F1 plus F2. So here we can see that the maxima here is aligning with the 11, exactly 11, and here as we go below, this maxima is present with exactly 9 kHz. So here we have completed our task 1.
And we can see the description of the differentiator based high pass filter. For this, we connected the output of the analog multiplier as the input of the differentiated circuit. This differentiator circuit is connected by referring this. The power supply pins and the output pins, input pins are connected to the respective pins, as you can see. This is the power supply, and this is the output, and this is the input wire, and these are resistances and capacitance. Actually, the cutoff frequency, which is 1 by 2 pi RC, is approximately 15,000.
Now for flattening the gain at 18 kHz, now we will flatten the gain there, and we will say that the gain at 18 kHz is equal to 1. So now we will use the capacitive reactance and the resistance to get a formula as shown in this calculation, and we will get an calculation wherein now due to the availability of the resistors and capacitors in the lab, we choose that the capacitor is 100 nanofarad and the resistor which is present in the frequency response is 1000 ohm. Now by doing the mathematical calculations, we obtain that the R1, which is the gain flattening resistor, is around 900 ohm, which is near to 890 ohm, which is available in the lab. So we use this combination in our circuit.
The observations we made from this differentiator based high pass filter circuit is that you can clearly see here the channel 1 shows the multiplication of two sinusoidal waves, and channel 2 shows clearly a single sinusoid.
So now we will analyze the sinusoids which we have obtained. As mentioned, yellow wave below is the multiplier output and the input of differentiator, while the blue wave is the output of differentiator circuit. We clearly see that the blue wave is a pure sine wave but with some noises, and using the measure function on oscilloscope, we see that the frequency shown here is 17.62 kHz, which rounded out to 18 kHz, considering some elements of some lower frequency. Clearly the sinusoids can be compared, and we are assured that the differentiator circuit has given the proper output.
Okay, so now we will compare the FFT. So as you have already seen that in the sinusoids, we can already see that we have filtered out 18 kHz perfectly. Now we will see in the FFT. Now this is the FFT of the, firstly we will check of FFT of channel 1, which is the input. So in the input, we can see that this one, let cursor see, this one is perfectly 2 kHz, and the final one is 18 kHz, as we have shown in the question number 1. So after this, we will check that how is the FFT for the channel 2, which is our output. So in our output, we can clearly see that our 2 kHz one is very much minimized because the gain has lowered a lot. Now if we check that the frequency, the maximum frequency which we get here is the final frequency which we are getting here is properly 18 kHz, which suggests that our high pass filter has worked very well. And thereafter we can say that, and after this we will say that our high pass filter has worked very well, and we have got a perfect sinusoid.